Okay, welcome back to my channel. I really like Cursor AI, so I try to improve a bit what I have been doing in my previous video. And I will show you the improvements that I brought to the model and to the code in general. So you remember that so the Python script was creating some graphs that were displayed uh, so during the execution of the program. And I wanted to make sure that I can see the graphs even after the script is over. So I asked it to, as you can see here, there's a prompt modify the code to save each plot into a file. And you can see that it's indeed what it did. So for each, so actually each period that was tested, so 1 day, 5 days, etc. in the original version, it basically changed the code so that the plots are saved. So you can see here that it's calling the savefig function to save the plots, and it does the same for all the plots that are created during the execution of the Python code. Now, the other thing that I asked it to do is, so here's a more longer prompt, and there are two things. One is I wanted to have more so testing set compared to the training. And the second one is I wanted to evaluate the performance of the model, and I ask it to simulate what would happen if I start with a $100,000 account, and based on the predictions, we would invest in the stock, but only if the predicted return is positive. Otherwise, we just keep cash in the portfolio. And I wanted it to create a graph that shows the evolution of the value of the account. So the graph that I showed here was, for instance, this one where we see that roughly, so we can guess that actually here the value is changing, so it holds the stock, and at some point we've got some constant value for some period, and this is where basically the return is negative, and so it's not invested in stocks. And here you can see that from 2020, so the model is expecting to see a negative return. I think that we can see here if we go to the graph of predictions with so 1 day period, and you can see that we start on the left with slightly positive returns, and then progressively the returns get negative. So at some point after 2020 around here, you can see here that indeed, well, the returns are always negative in this in the result of the model. So it means that we never invest again in Apple, and so in Apple, and then the result is that after 2020, the portfolio value doesn't increase. But we can say also that there's a significant increase, so there's a double increase of the portfolio value between 2018 and 2020, which is not really, doesn't sound realistic. Actually, just in a few years doubling the stock price doesn't sound like something that really happened. And I've tested other, so I've changed also the test periods, and I have these 20 days. So here's the same thing for the 20 day, and you can see that here. So the scale is a bit crazy because it's e to the 16. So that's a lot of zeros. It's more than trillion. Trillion is typically e to the 9, and here it's completely crazy. And we can see that so the initial portfolio value, which is 0.1 million, is almost zero on the scale, and then it completely explodes at some point. But I'm pretty sure there's an issue here. So this is an issue that I'm currently trying to solve. And I have to mention the other changes, and I'm sure we can see them later. So the model as well. Okay, there's another one. The model, I wanted to save the model in a file because I don't want to train the model every time I create a new graph or something like that. So the models are here. These are basically the result of the optimization of the model. So the stochastic gradient, after a certain number of epochs. So I don't keep track of the number of epochs, but I have increased compared to the last video where I wanted to have something like quick and dirty. This one is more like a proper model, and it took something like 10 minutes to train, so really not still not a great deal of time. But here 50 epochs, and so it sounds more realistic for training this kind of model, even though I have to say that the data is not it's not so long because it's only here. So I'm doing from 2001, so it's around 14 years of data. This is not really a lot of data, but still, I think that so the yes, another thing which is, wait, the training history. So yes, ooh, so there's no. This is the MSE, so the raw by epoch. And I don't know why, but there's epoch 1, so is it because, all right, so it's because probably it loads the model and then it tries to recompute this graph, and it shouldn't, because it's only the first time that we can create this graph, and after the first time it's created, it shouldn't try to do it again. But this one is the motor performance by prediction period. So I'm trying to kind of analyze the performance of the model with different indicators. So this one, unfortunately, so it has to be done again. But that's not my priority. I can just keep that in some kind of to-do list for improvement of the code. And what was more interesting to me is, so first, as I said, saving the model so that we can load them directly from the file instead of training every time I run the script. And then create a graph that shows the evolution of the portfolio value during the simulation. So we have seen that. And then actually there were some errors. Strangely, when I paste the error, it doesn't appear here in the prompt, but there was an error and it tried to solve it. And then, okay, here, that was yet another error. So the error actually was not solved completely, but the good point is that I just have to point out to the error, and then it's, okay, it finds out that, okay, this is because it does this or it doesn't do that, and let me fix this. So it's pretty great that there's a lot of explanation about what's going wrong, and it always proposes correction, and the correction usually most of the time is working fine. Here it wasn't working fine, and there was still an error, so I had to modify a few times and go back and forth, but in the end I managed to get something working. All right, so next update is the graphs. So I changed the number of prediction periods, and the graphs were not updated correctly according to that. So I had to do several iterations to get that corrected. As you can see, 3 prompts, and in the end, I got the proper graph like this. So 6 subplots, and now this is working. So I'm very happy about this. Then I had an error, and right, then I wanted to change the right now. This something was because there was a training and validation and testing. So I have 3 different subsets of the data, and I wanted to make sure that you know, it's properly reflecting the 3 different subset and the size, and it changed the code so that it's easier to understand. So what is exactly the split? So it becomes clearer. And then right, so this one tell me what is the evolution of MSE by epoch. So it created the graphs, but as I said, I think that it creates the graph even if we load the model and the data is not present actually. So it should not overwrite something if it's if it hasn't just trained. But I think it's easy to change this code to just give a prompt for improving that. And in simulate portfolio, does actual returns contain the return value for each day in the testing period? Because I just realized that the error, so not this one, it was the case of the 20 days where we've got an explosion of the portfolio value. I was thinking if maybe the returns are not computed correctly. So how it works is that if you look at the code, and it's stating clearly here, there's a loop for the simulation of the portfolio value, and the loop. So the loop here is so let's look at the previous. It goes into each of the items of prediction, which corresponds to each period. Each sequence that there is in the original data, and we'll have a prediction and actual return for each of these sequence. But the sequence are apart by 1 day. So basically, in this loop, we loop through each day in all data, pretty much each day. But you can see that the portfolio value, in case we decide to invest, so because the return is positive, it's multiplied by 1 plus the actual return, where the actual return is not 1 day. The actual return is computed as it says, as it explains, by this percent change, and the period is the self-prediction days. So which means that here we're basically applying like a potentially, so this one is 20 days return. That could be much higher compared to a 1 day return, obviously, and we're applying that to the portfolio value, and we're doing that every day. So this is wrong, and it tried to correct once, and it did, and then I got an error in the output as well, so I had to correct that. But then I sent this prompt, are you not applying the actual return, which corresponds to a period longer than 1 day, to the portfolio value, which is updated every day? And it says, you've caught a critical issue. You're absolutely right. In the current implementation, we are applying multi-day returns, as for instance here, the 20 days return, to update the portfolio value every day, which is incorrect. For example, if we are predicting 5 days return, we're applying that 5-day return to update the portfolio value every day, which leads to incorrect compounding. And I think this is the reason why I saw that error here about the super high compounding, as it says. So even this one is, yeah, that's the right one. This is 20 days, and that's wrong. And so it proposes a correction, and this looks good because so we only update the portfolio value when we're at the start of the new prediction period. So it kind of split the data into prediction periods. And here, if we're at the beginning of a prediction period, then it's going to run this line of code, which updates. So we're not going to. So we're going to update the portfolio value at the same frequency of the return period, which is indeed what we want. Okay, so I'm going to accept the file here, and I don't have to retrain the model as I explained. I just have to load the model, but I want to update here. So what is going to be updated is just the simulation. I need to, so again, so a bit struggling with the folders and stuff, but this should be the right one. And so I was saying it should load the model without, okay, testing, fetching, relieving, loading existing model. So it found the file, so it's loading. And then that's it. And then it applies it does the simulation. And okay, but again, we've got that error. So I got to point that out, something like this, and then it should be able to correct that. But this error occurs quite a lot after modifying the code, but each time it can correct it. So it's a bit surprising that when it modifies the code, it kind of introduces this error quite a lot. it doesn't realize that, and I have to point that out so that it understands and it corrects it. So that's kind of a bit of I'm gonna say drawback or kind of a limitation of this AI. All right. So good. So I hope now we don't have crazy portfolio values. Let's look at the portfolio comparison. Okay, that looks good. And what is the best one? 20-day is the best, and it's 4 times basically. It's 4 times, almost 4 times, 400%. Is it a 300% return? And what do we want to do? Right, so we can see here. Okay, so obviously the period by which we apply. So sorry, we train the model actually is going to so the frequency of the return is going to be a key aspect of the model, and when we change this frequency, we definitely completely change the result of the model, which is not a good feature because the model should be stable when you kind of change the parameters of the model. And I see this prediction period as one of the parameters of the model. Now you could think, okay, I'm an investor and I can only change my portfolio composition every week, say. But I don't. It doesn't mean that you want to predict what happens in 1 week. You may want to say predict for next 2 weeks or even like 2 or 3 days, but still want to invest to change the trading composition every week. So it doesn't have to be exactly the same. But now it's probably more consistent actually to say if you are looking for a 1 week return, you are looking at data of, because one of the first thing you do before training your model is computing the returns. So the return is basically what you see, what represents the market for you. It's the 1 week return. You don't know what happens between that week, but you know that 7 days, or let's say 5 training days from now, you're going to have that amount of return. And it doesn't matter what happens in the middle. Now, personally, I have a kind of issue because if you look at 1 day, okay, it's pretty clear that we trade every day, so it's fine. But if we look at the longer pairs, so the 20 day is more interesting because it has it's the highest performance. There is also, I have to say that it's mostly a positive return, so that looks good. But there's some negative. There's some steps as well on the graph. But it's probably because it's maybe because it's not investing, because it only reinvests at certain periods. So do we see that actually? Wait, if we don't trade for 20 days, then the portfolio value is going to be the same, and then we'll see some step. But it depends on the unit of the graph here. I don't think it should be a difference. I think that this level, so the steps corresponds to mostly negative return, where we don't update the portfolio value. But this is typically something that we should be able to see here. If you go on the 20 days, even though it's honestly it's very random, but you can see where it really oscillates. No, actually here after 2020 is pretty much positive return. So that's you can see it's very different from like 10 days, which completely unstable, or the 5 days which is almost always negative. So it's very difficult to say why in this case 5 days return and a 20 days return give so different result apart from the fact that we know that it's theoretically impossible to predict the evolution of a stock price, especially for 20 days. So this may be some kind of spurious result or data that we see here. So it may not be interesting actually to investigate further than this. Just saying that we're trying to do something that doesn't really make sense in the first place, okay? But that's not my purpose, honestly. I'm trying to build an AI model that makes sense. I'm just starting here, doing very basic prompts and seeing what we got and trying to improve things little by little. But knowing that there's a clear limitation about what we can do at the moment, given that we have to find a way to kind of be smarter than just the basic approach, right? So what I think also in terms of I want to know how unstable is the model. Like that's one view basically, because when we change the prediction period, then we've got so different results. So if you're an investor and you have to decide the prediction period is which one would use, and you could say, well, it looks like 20 days is the best, so I'm going to use 20 days. But just think about it. Just think it again, because if it's 10 days, it's completely different result. And how can you trust actually the result here? How can you trust anything about this? Um, but I tend to agree with the fact that so if we go back again, we can kind of see some trends here, and it's true that given the potential behavior of mean reversion, for instance, if you are this level, if you can find this kind of information where when you got 10% return, you're basically saying that, oh, it's very likely that next is going up. So the kind of cycle with some kind of frequency that you can identify, we may need to, we could do some kind of more advanced numerical analysis where we see that this data has a certain number of oscillations with some frequency, and we could come up with, okay, what are the main frequencies in the signal. So this is basically the topic called signal processing, and this is something that could be done, but that's not really what I want to do. Really want to use the model and have some strong measures of the robustness of the model without trying to explain actually what is going on behind the scene. So I know this is not easy, but I think that I need a bit more indicators at the moment, a bit more diverse set of data that shows that the model is definitely something we can rely on. So for instance, the 20 days like this, but I like to see other frequencies like and maybe 25 days or 15 days, we can be more granular on the upside. That's one thing. And by the way, the 30 days, so the return is 30%, so it's not really great. And the question is why? So why do we have that difference? Like when we can see here that kind of when we use 10 and then 20, we've got a very interesting increase in the portfolio value. But then when we go to 30, then it doesn't work anymore. And why would it happen? And it doesn't make sense if you in terms of stability of the model, it's just like you can't really choose any of them, because just changing a bit of parameter would really completely change the output, and it's not something that you want when you apply your model. You want a minimum of stability. So what I'd like to do is we could increase the number of days and train a model with more different values of the parameters. That's one thing. But also think something else, which is potentially maybe not as much impactful, but even if we look at the 30 days, basically it's like there's only a subset of days when we're upgrade, we change the portfolio composition. But the question is, when do we start? So we start here. This is the first day. It's 2018. And I guess this is because my testing set is only, how much was that? It's 20%. Was it 20%? 30% of the whole data. So you start from 2001, and then we've got 24 years, and it takes what 30% of that. So the 20-year, this is 20, it's like 6 years, kind of 6 years, yeah. So it's around 6 years. So that's 30% of the 25 years. 6 years. That's what we see. So that's why we have this. We start from 2018. But how about basically these 30 days actually is done every third day? But does it depend on the start date? If we start one day later, we could have potentially like a slightly different expectation of the return. And if we start in the middle of the period, it would be 15 days. We have some kind of different return. And the fact is that if we've got some very abrupt like changes in so we can see there is something like if you if you were actually training a few days after, you could see the jump. You could be after the jump or before the jump, depending on that, on just a few days difference. So I want to know what is the impact of these jumps, and for that we could basically say that add another kind of dimensional parameter, which is here is basically starting. So it's updating the portfolio at the start of the new prediction period, but I want to shift that period. I want to kind of decorrelate, not decorrelate, but shift really the timing of the portfolio recomposition in versus the list of dates that we have here in the prediction. So I want to like add some kind of so shift this so that this code is run in the middle of these pairs. All right, so I have to explain that to the EOI model, and so the portfolio rebalancing is performed starting exactly from I equals 0 and with frequency prediction days. But I would like to see what happens if the rebalancing is performed not from I equals 0, but from I equal j, where j is a parameter that can be can vary within a range that can vary in a range between 0 and prediction days. What happens if the rebalancing is performed not from I equals 0, but from I equal, I should give an A maybe rebalance shift, not shift, it's weird, but offset, rebalance offset, which is a parameter that can vary in a range between 0 and prediction days, well, -1, I guess, 1. And I would like to loop on all possible values of rebalance offset and plot in a graph the portfolio value in function of rebalance offset of the value of the final portfolio value function of the, okay, the final portfolio value should be enough. It doesn't have to be the whole history, because we could ask to have this kind of graph, but here, so for the purple one, not the purple, the brown one, we could have like many, so 29 different lines that correspond to the brown one, but a different offset. And the graph would be difficult to read. So I'm not going to do that. And so it has this rebalance offset, okay, and then it becomes a parameter, and then so let's look at other parts of the code. So here, analyze rebalance offset. So is it looping? Yes, in offset. Okay, so okay, right, exactly as I said. And then it has the final value, so we can have this stuff offset plus the corresponding final values, and then it can create a graph that would performance versus the rebalance offset, and we can see the impact of the rebalance offset. Okay, cool. So let's see what we get, and I hope that we don't have an error, because we would need to ask again to solve the error, even though it's not so much a big deal every time, but it's just like, okay, yeah, now it's working, so that's cool. I don't really know what kind of graph I'm getting from this. So okay, there's not one graph potentially, but this for each so we have potentially one additional graph for each prediction period. Okay, let's look at that. So okay, what is this? Rebalancing offset analysis. What is this? Okay, so interesting. Portfolio performance versus rebalanced offset, and okay, so in one day, obviously there's nothing. In 2 days, it's a zero, either 0 or 1, but there's no change. In the 5 days prediction, we see that there's a small. So what is the final return? It's a return. Okay, so all right, and then 10-day prediction, we see that wow, there's a lot of impact on the 10-day prediction of the start. Just 1 day, so 1 day shift could really create a great difference in the final return. So this shows how the model is really not stable in this regard. And 20-day prediction, we can see that it oscillates between, let's say, 170% and 300 and like 40%. So the initial, the zero, was what we were looking at originally. So I guess if I go back to this, so here, so here is the 300 and kind of 70% return that, so we should see here. Wait for the 20 days. So it's 200. Sorry, it's 270. I don't know why I was thinking of this. Look at 370. So I'm a bit puzzled here. And which one is it? Is this? So in the end, this one I don't know anymore which offset is used for this one. But so what is the value of rebalancing offset used for the graph? So I'm going to give the name of the graph, and then it's going to tell me if it's a specific value that was used for this one. So it's 0. Okay, so it's 0 is the base case, and then I don't feel like it's consistent unless it's not computing. So here we make a profit of okay, we make a profit of 207,000 or something, and this is the 270%. Okay, now I get it. Okay, so we're here, and you can see that when we change the original, when we shift the portfolio rebalancing, kind of get different results. Okay. So just the timing, actually, the timing of the rebalancing, like do you it can have an impact, basically quite a significant impact. And for the other one, 30 days actually doesn't make a huge difference. But it's interesting because we can have negative values. We didn't have that with the other ones, but that's the case here. I'm not sure what the triangles are for. The triangles, I have no idea what the triangles are actually. What are the? Okay, let me ask. So which one is this? This one. Whoops, sorry. Let me go back to cursor. What are the triangles? Come on. In this graph, I have to make some effort to better write named. Okay, like this. Markers indicating the maximum and minimum returns for each prediction period. So the green are the maximum return and the red are the minimum return. Minimum return and maximum return. Okay, all right. So, okay, we've got the red one and the green one there. Interesting, there was no legend for that, but that's fine. And you can see also the longer the prediction period is, the more we have the possibility of having a different offset for the prediction period. So obviously we may have more uncertainty in the longer period. And that is compounded with the fact that we know that it's potentially more difficult to predict something more farther in the future as well. All right, so that's it. And what can I conclude from here? I think that this is a very interesting result. So as I say, I like to have more prediction periods and see what happens if there's kind of best one. And that's one thing. Otherwise, it looks like, I mean, in terms of trend, that we can say that, well, actually, I should ask it to create a graph of the Apple stock price. But we'd see that it's okay. So here I need to go to the max. Okay, so basically we can see that since 2001 it's almost always increasing. So there are some small decreases in the stock price, but basically if you were just buying, you would have how much is that? Like, I'm not sure this is relevant. Okay, but it's crazy because you would have something like between $0 and $200. So it's okay. That's how much is that? 400% return. That's really a lot. And another 400, but yeah, something like that. So I could also change the code so that we have the basic strategy of always buying. So let's do that. Please add an evaluation method for the simulation. No, it's not even interesting. Actually, please add. I want to please add on the graphs of final performance of a simulation. Please add the graph on the simulation performance. The case where we hold. So we buy the stock and hold it during the whole simulation. Is where we buy the stock. Okay, so let's see what it does. What I'm expecting is that it's going to just compute the basic return of the stock between the start and the end. But the problem is that I think it doesn't know the stock price. It knows the return. So in the simulation, we see that it's using the returns data and not the stock data, which surprised me a bit because we could basically just compute the actual return from the stock price. We have the stock price. So I'll modify the call to add a buy and hold strategy as a benchmark for comparison. We'll need to calculate the buy and hold returns. So how does it do that? Am I looking at the right file? Yes. Okay. So where are the changes? Here. So what is the red? These are the actual returns, but again, I think this is wrong because it's looping through the actual returns, and we know these are daily, and the red is not daily, so it's doing the same mistake. And why doesn't he use the stock price very simply? So I feel like it didn't store the stock price, or it didn't keep the stock price. So after it trained the model, basically just forgot about the stock price itself. So the simulation doesn't know how really to use the stock price, and it only use the returns because this is what we give to the model, and the model knows about the returns but not from the direct stock prices, which is an issue. I just want to remind myself is how did it work with the data. I think that it originally prepared the data, and here it's, well, no, actually, where does it collect, where does it download the data? Okay, so I could just guess fetch data. Okay, here, so it does this. Stock.history and lazy. What is this? Lazy. I'm not sure. Wait, where am I? Base.py. Lazy load price history. What kind of module is that? Care base. Is this Y finance? Yes, yes it is. Okay, cool. But that's not what I wanted. I just wanted to. Okay, and it's not stored, by the way. I could improve it by storing the data instead of reloading every time. So it's fetching the data. Okay, cool. And then creating the features. But I feel like what happens to this? So the DF is contains the originally the price data, but I feel like it's when it does that, the close. So we have the close here, and then do we still have the close, or is it just forgets about it? No, we still have the close. Okay, cool. Can I go back to where I was, please? No. DF. So DF contains the stock prices, and okay, so we have here. So for instance, here there's already a kind of last return. We already have that actually. And how is it computed? The last price. Oh, that's the last price, and it's assumed that yes, we use the last prediction, and this is the last return, and then the predicted price. But this is with a certain period, so this is a prediction for the period. Okay, but again, we've got this issue that it's not necessarily. It depends on the prediction period. Okay. All right, and I don't want to do the same thing here because it's wrong. So That's a bit bothering actually. Why is it not just using the stock prices? Can you? Okay, I think I have to tell it. Can you compute the buy hold value by simply comparing the stock price at the beginning of investment period? Oof. At the beginning and the end of investment period instead of using returns, since the returns don't have the same frequency, or let's say the return depend on what was the name, offset, the offset, what did I call that? No, I don't remember where was that. Okay, offset, rebalance offset. Okay, so I'm going to point out, okay, and ask, can you do something differently? It's a better approach. We want to calculate buy and hold performance independently of any rebalancing strategy. I'll modify the code to use the actual stock prices instead of returns. Okay, that's okay. Sounds better. Okay, so what is it doing? Let's have a look at the code. It changed here. So buy and hold the final price minus the initial price. Okay, that's exactly that. That's then multiplies by the initial investment, and yeah, okay, this makes sense. Buy and hold return. So which one is it? Is the rebalancing offset analysis, and then okay, it's going to add another horizontal line for the buy and hold performance. Okay, cool. There's another update here. What is it? So again, this one is portfolio comparison. Is going to do the same thing. And all right, so use the close prices as the right dates. Test dates. Then is it like, no, is this all the prices, and then it used the first one and the last one of the test dates periods. Hey, let's hope this works. Okay, now let's run. See what we have. We can expect a very high return, really, from how much is it, like investing in Apple from 21 to 2025. Obviously, it's going to be a terrific return. So we have an error again, and okay, where is that? Okay, I'm not really sure why. Why is it fetching again? Because I thought I just did the job. Basically, did the job. Buy and hold return. So this is okay. The black line is like if you just invest, whatever happens. All right. So yeah, it's kind of a mess. There's one which is closed, which is the 10-day prediction, with basically something similar, or the 20 days, which is kind of still similar, but then for the 5 days or 30 days or even less, it's just a mess. But also the idea is that I decided to invest if it's a predicted return, which is negative, which is positive, or otherwise I don't do anything. So we could use a different rule. Basically, we could say that well, we have a certain amount of portfolio value, but I want to invest, so let's say all in Apple if the portfolio return, sorry, the predicted return is above a certain threshold. So I don't know, like maybe more than 1%. Okay, you just, or even we could say something if it's greater than minus figure or whatever, minus 0.5%, because we can still have some margin of error. But we're optimistic about this stock in particular. But zero is kind of a bit natural value to use as a threshold for this. But we could have more like smarter strategies. So the higher is the predicted return, and the more you invest in the stock, basically. So if it's only zero, it's like, okay, say you don't see higher stock value or lower stock value, and you don't want to put that on Apple. You could buy well, just government bonds, which are safer, a guaranteed return. All right. So that's another thing is in terms of really what we want to do in terms of investment strategy, we could decide to have something which is better. But at least here we see the buy and hold. So where's that? These days. Wait, no. Sorry, the period again. So I'm a bit lost in my graph and stuff, but that was for the period. Or no, this one is an old graph. I need to close all my graphs because can I close out that? Yes. Oh, so yes, I was thinking it's from 2018 and then up to 2025, and then we've got a 400% return basically if we follow. So this one is 20 days, and that's one of the best return 20 days. This one, but so this one, sorry, here, but we could have even a better result with a 10-day prediction, and using also a certain kind of being lucky, because it's just like when when if you decide to trade every week, but somehow you end up on the right day. You could start the next day basically, but you decided to start on this particular day, and you've been more lucky than for the other days. That's the type of uncertainty that we get from this model, or say from the not really the model, but the valuation or the uncertainty, because when we predict the 7 days or 10 days ahead, is, well, we don't know when we're supposed to start investing. So one of the issues maybe here is that we should say, well, actually, could we trade every day and based on the 10-day prediction or 20-day prediction, because it looks like 20-day prediction is better. So yes, is something also that we could consider. This would be kind of equivalent of looking every day at a moving average and saying, okay, so I think that it's going to the moving average is a certain level, so we'd like to invest because of that. So in that sense, we don't have to align exactly the portfolio rebalancing, so the trading itself and the prediction period. We could decorrelate them, and that's probably one thing that could be useful. So what does it mean? It means that we would have a rebalancing period parameter and prediction parameter, and one of the limitation of the current approach of the code basically is that the return are only computed for the prediction period, but we'd like to have the prediction so the return for the actual return. So sorry, we'd like to have actual returns and predicted returns. We have absolutely different, which are not the same period. So the actual return will basically depend on when you rebalance. whereas the predicted return would be basically one parameter of the model, and you could use, you know, whatever you want. So this one is a prediction period, and it's like when you compute the moving averages, what kind of period you want to use. So we could also decide to predict 1 week ahead or 1 month ahead, etc., and do all of that, and we have a certain number of models, right? From each of them, and basically we could decide to use that in the model. So train a model that basically saying that, okay, which one is the best? Which one should we use from this prediction pairs? Of course, it's obvious in a way because you can see from the graph that it's very obvious that, for instance, we should use the 10 days, so that here we don't even need an AI model to find that. No, it's more optimization-ish. So we could have a bunch of these models and say, well, then the prediction looks good. Actually, on every day we can have the prediction of a certain period, and right. So, for instance, do you only invest if all of them are positive? That's one question. Or do you only invest, or you invest if any of them is positive, so if they are not all negative, for instance? Or you find some kind of composite ratio, so you compute an average of all these returns. Then you have to select the weight. That's where you can find an AI model to sorry, to optimize the weight. That's another possibility. So I think I want to ask this to, instead of reusing the actual returns, to rewrite the simulate portfolio function so that so rewrite the function simulate portfolio so that it takes an additional parameter, which is the portfolio rebalance period, which means that the portfolio positions are only potentially change every portfolio rebalance period days. And then I'm a bit worrying about how I would recompute basically the portfolio value. And the portfolio value should be updated by the return during that portfolio rebalance period instead of the return given by actual return. Instead of actual return. Okay, so I'm not really sure if it's easy to change the code because it's a very complex prompt. modify it to handle a separate portfolio rebalancing period and use the correct returns. And I'm expecting that it's using the directly, so the stock prices. If it doesn't do that, I have some concern on the validity of the code. All right, so we have this new portfolio rebalance period by default. It's known. It's a bit weird. Oh, then it would take the prediction as okay, fine. All right, so here, so it's updating every rebalance period. It's good. And if calculate the actual return for this rebalance period, we need to look ahead rebalance period days to get a correct return. So it's doing the same error again, right? It's looking at the actual return. What is it doing? I think I can accept, but does it? Over the entire rebalancing period, really? The actual returns. What is the actual returns? Okay, I have to point that out again in simulate portfolio. Do you assume that actual returns represent daily returns? How about using directly reading the stock price to compute the actual returns? You raise a very important point. That's good. Looking at the code, there's a potential issue. Welding, yes, contain multi-day returns, not daily returns. We're currently using these multiple daily returns as if they were daily returns, which is incorrect. Okay, so it recognizes the issue. And what is going to do? Instead of using the pre-computed actual returns, we now fetch the actual stock prices. Okay, so it actually reads the good. Yes. Well, okay, so this is going to fetch the data again. So are you kidding me? So it means that it's going to load the data again just for this. Nah, it's kind of crazy. So the portfolio level is not updated using the correct material. Is it? Let's see what we have. So here, predicted return. Yes, yes. So okay, yeah, this one, yeah, that's the actual return. But the problem is that yeah, so instead of loading data every time the function fetch data is called, can you store the data into a file the first time it's called and load from that file the second time it's called? Okay, so this should be easy. This is something that I asked already for not this, but the models themselves. All right. Okay. Okay, and then it should be somewhere in the file. Okay, I'm going to run this. I kind of have high expectations for this. We may expect some error here or there, as usual. loaded cache data. Okay, cool. So it seems that it loaded from the file, possibly. Yes, what is this? Seriously. Is it doing this because we have different values of rebalance of set and stuff? Yeah. Okay, so there's an error, but I'm not sure if it affects really the whole thing. How many values? So how's the simulation? Portfolio comparison, and doing the simulation, I want to know what are the different values. Well, I will see that. So this one is the same result, okay, but so where's the actually? I don't see much change in the, what can I say? Yeah, so the question is now, can we simulate? So it can simulate with different initial, rebalance. No, not this one. Pair for portfolio rebalance period. So is it really changing it? Is it really applying this? No, no. There's no parameter here. Okay. So what I'd like to say is same thing as the rebalance offset is the portfolio rebalance period. I want to see it different. So in addition to existing graphs, please show please vary the parameter portfolio rebalance period from 1 to 30 and display the corresponding final what is that, portfolio value. Create a new function to analyze and plot the portfolio performance across different rebalancing periods. This will help us understand how the frequency of the portfolio rebalancing affects the overall performance. That's exactly what I wanted. All right, thank you. I'm going to accept that very happily. And okay, wait, there's variables, but would you like to make any adjustments? I don't know. I'm going to first. I'll look at the data. I think I'm pretty close to getting something that is quite good in terms of explanation of what is happening with the model. And especially the uncertainty, I think this is something that we really need to care about when we build a model, that is it really able to explain or not, and in what conditions, and how sensitive is it to potential parameters. So I guess that it's creating the graph now. So we have this portfolio comparison, and is there a loop on the portfolio? Where's the loop on the portfolio rebalancing period? Well, I don't know. I can't see it. Basically, it should be this code analyze rebalancing periods. Okay, so there's a function that does that. Okay, so it uses different periods. Really use okay, every day, just as I told it, from 0 to 30. Okay, but 0 is no, from 1. Yeah, 0 would be ridiculous. Okay. Where is it? Okay, this one. Right, good. So this one is good. Is using the 10-day prediction period and rebalancing like every 27 days. Why? I don't know, but that the performance is great. It's even greater than just buy and hold. All right, but here, so again, we've got some variation when we change this rebalancing period, obviously, but not as much as I was thinking. Whatever the rebalancing period, we can see that the 1 day and the 2 days prediction periods are pretty much useless, and then the more longer prediction period and the better it is, except for the 30 days prediction period, which basically doesn't work well for some reason. So we have to stop at 20 days. This is, I would say, probably on average the best one. But this is one dimension, and the other dimension, if you remember, is the rebalancing offset. But this one is, well, it really plays a role, yes. Here on the 20 days, we see that it's not so as volatile as the 10-day. So is the 10-day more volatile than other? Here it's also more volatile in terms of the rebalancing period. So well, this is for Apple stock price, but we have to see what happens if we have much so many more options to possibilities to buy other stocks. Basically, this is not the only stock that we have in the universe. That's one thing, and the other thing is that we could increase the prediction performance. Sorry, the prediction accuracy or the prediction power by adding all the variables as explanatory variables. Here we only explain the Apple stock price by itself. And these results may not be very strong actually. So say if I train a model on a different period, so if I basically go to the code and here for instance I change the start period, so I train from a different period, then do we still have this kind of profile, or is it a very different profile? That's another question that we have. So there's another parameter, which is start date, from which we have trained a model, or training basically with a different period. Could be a reason for the change of performance. And we could have a look at this graph again. So I could create this graph for, so each graph like this for a different period of start date for the whole analysis. So I could do a loop on that. That would be interesting. We have a lot more graphs basically, but we also, to simplify things, we could just kind of compute the average of all these lines. So the average on the rebalancing period, but also the standard deviation would be interesting, because even if the average is high, but for instance here there's an outlier, the average will be very high, but the standard dev as well is high, and we don't want high standard dev to avoid the kind of model uncertainty. Right, so I don't think I'm going to do that now. I think I'm going to close to stop here the video, and I hope that it was a good illustration of how we can explore the different limitations of the model, trying to see how we can improve or have different perspective, change the parameters, but also seeing the kind of risk that there is in training models and the different parameters that we can have, not only in training but also evaluating the model. So so trying to find different strategies for the evaluation, but again this is extremely limited because it's only one stock. So once we have this kind of framework for proper training and evaluation, we can basically run it on much more data, and we will need to expand the scope of the input data, and also extend the potential scope of where we can invest. But we can do in several phases, in several steps, starting from just increasing the input, and just assuming that, okay, when do we invest in Apple based on all the data, the extended data that we give, something like that. That would be a first step, and then the next step would be to say, okay, we have a universe of stocks where we can invest. We don't have to invest in Apple. We have other names, but we have to be able to predict um, the stock price for all these names basically, and that becomes a bit more difficult because some will be predicted well and some not as well. And how do we evaluate a model when some of the stocks are we cannot predict everything at the same level, so we have to do some kind of some kind of so weighting or some kind of trade-off or some kind of um, arbitrage between the different prediction results across the name. Right. So this is pretty much it. Just again, I'm very happy with how this cursor is working. I haven't gone that far with the other options, which, for instance, are Copilot with VS Code. I haven't tried so much with Manus as well, but now that I have this kind of framework where I know what I'm doing and I know what I want to see and the things that I constructed step by step here by asking several prompts. And the idea now would be to kind of doing a synthesis of all of that and to come up with one single prompt that could be able to create this code, whole code. So there's a lot of code. How many lines do I have? Is 700 lines of code, and can I come up with just one prompt that could do all of that in a single run? That would be interesting because then I could try with other AIs basically without the need to repeat this whole thing. And also, the prompt will kind of contain the knowledge that I now have from trying stuff, repeating and and always completing and make improvements on the code. And that prompt would basically contain the knowledge of, okay, what is the best that I can do. So that would be quite a useful prompt, I think. So that's what we have remaining. There's a lot of stuff remaining, of course. There's always a lot of stuff that we can do, but here at least we can see how I've done something that is quite powerful. I think that this application of what I would call the vibe coding or something like that is a good application. And so even for somebody who doesn't really know very well about coding, it's quite interesting to see what we can do, and that this AI agent, I would call it, is understand very well the prompts and understand obviously how to code and to debug and to improve the code. And even if it kind of does some mistakes in the logic, for instance, in computing the actual returns that are not in line with the period that is supposed to represent. Well, it's up to the user again to be smart and look at the result and trying to understand what is being done. So it's kind of up to the user to test the model as much as possible. There's a lot of testing to be done where when you get some code and you have no idea how it's built, you just expect that your prompt is being, processed accurately, then there's no bug in the end, but that's not true. There are some bugs, so we need to be careful and we need to be aware, to be alert, and to make as many tests as possible. The first code that I got from this was not tested enough very clearly, and so it's really up to the tester the user to be a tester as well, and to not trust any code at face value without making sure that it makes sense. And I'm not even sure if there are still some bugs. I trust that is not the case, but if I had to decide how I put my money in the financial markets, that would be very careful, even more careful than what I am currently. I would do some basic sanity checks, like making sure, for instance, that the model has the right data, that the data is not corrupt, or that the data is processed in um, realistic manner. For instance, that making sure that the AI model does not use uh, does not train the model using data that is not supposed to know at the time it's training the model. That's very important that you don't feed your model with data that is ahead of time at the time of testing or training, because otherwise your result will be very good, really excellent, but they will be wrong, and you can't train on that. You can't use that to actually make the actual predictions and train on the basis of that. So this is one very important feature of the model, is that it's realistic. The simulation really tells you what would happen if you really were using this model to actually trade. That's a very important requirement, so we need to be careful about that. That's one of the warning that I would give, even though what I got here is very encouraging. And I'm going to reuse this as a basis for in the later videos to build something that is stronger with more names, with so increasing the capacity of the model, but also so I may have to, because of that, to need more computation power. I'm using a Microsoft Surface, which is not enough to upscale the model, so I may have to look into issues such as the GP using GPUs. I don't have a GPU, so I may have to consider how I can find. I know that Google proposes using GPUs, so this is one thing that may become uh, a strong requirement at some point when the model becomes big enough. All right, so that's a lot of things, and I can now think close the video and just say that this is very interesting, and I look forward to again working on this code and improving it, and I will make more videos about that. So thanks for watching my channel, and see you in next video. Thank you.